where I'm going, but I do know where I've been. Living on the promises of the songs of yesterday. Now I made up my mind. I ain't wasting no more time. Here I go again on my own, going down the only road I've ever known. Like a drifter I was born to walk alone. Hello everybody, welcome to this week's edition of Video Notes for Mr. Flugum's General Chemistry class. That's right, ladies and gents, this is for Gen Chem. We're talking about molecular formulas today, and this is going to go on your science notebooks on page number 66. Well, thanks for tuning in, you guys, and let's go ahead and get started. Alright, got some fun stuff for you guys today, talking about molecular formulas. Alright, and here's the goal. We are going to find a molecular formula based on the data that we're given. So this is the percent composition that we're going to be given, as well as the experimentally determined molecular mass of a substance. So let's check this out. Alright, so here's our example problem. We're going to find the molecular formula of a compound that has these percentages here of carbon, hydrogen, and oxygen. And it has also been determined that it has a molecular mass of 230 grams. Well, how the heck do you do that, Mr. Flugum? Well, I've given you some steps here to kind of help you do that. Okay, and first thing is this, right? We're going to determine the empirical formula. Hopefully, by the time this is due on Friday, you have done that a few times. Okay. Second thing is this, we're going to figure out then the molar mass of our empirical formula. Okay, so that means take your empirical formula and add up all the elements, right? Then we're going to divide the molecular mass by the empirical mass. Okay, when we do that, we should get roughly a whole number. All right, and then we're going to take the subscripts of our empirical and multiply that by the number from step 3. That number that we got as an answer. Then last but not least, we'll just kind of check and make sure that our actual molecular formula adds up to the molar mass that we were given. So let's go ahead and get started on this. Okay, so first thing is this, right? Determine the empirical formula. Okay, so here's all the work that I did in order to find my empirical formula. Notice this is what we practice in class, or will be practicing, depending on when you do these notes, right? Change your percentages into grams by assuming that you have 100 grams of the substance. Okay, then convert those grams into moles, right here, right? And then, once we get the moles, we're going to divide by the lowest number of moles. In this case, that is 1.737, right? Which is how many moles of oxygen we have. Now, what I got when I did all that is this. I got 3, 5.5, and 1. Well, since it's basically a perfect half, I'm going to multiply everything by 2 in order to get whole number subscripts. So, my empirical formula for this substance is C6H11O2. Okay, now the next step is to do this, to find the molar mass of our empirical formula, right? Here's our empirical formula that we calculated on the last slide, right? C6H11O2. So I'm going to add up all of the atoms in that formula, and when I do that, I basically got 115.152 grams. Okay, so that is the molar mass of our empirical formula, step 2. Let's check out step 3. So here it says, step 3, we're going to take our molecular mass and divide it by our empirical formula mass. So we've got this, right? 230 grams divided by 115.152 grams. Let's see what we get. According to my trusty calculator, I basically got this, 1.997. Basically, that equals 2, doesn't it? I mean, more or less. Alright folks, so we are about to find our molecular formula, right? Here's our empirical that we calculated. What we're going to do is we're going to multiply these subscripts in the empirical by the answer that we just got, which remember was 2, right? So if we multiply everything here times 2, we get this. We get C12, H22O4. Now there is our molecular formula. I just have one more step, and it's not necessarily a critical step, but at first I want us to try it and make sure. So we're going to check our work here, right? So we have this. We have C12H22O4. What we need to do is check and see if that mass adds up to approximately 230 grams. And when I do that work and type it all into my calculator, I find this. I get 230.304 grams. Sounds pretty close to me. In fact, if we round, right, that rounds off to 230. This must be the correct molecular formula of our substance. Now, if you're thinking to yourself, man, that seemed hard, it seemed like a lot of work. It is. It's a multi-step process, right? And it takes some time and quite a bit of calculation. But it's something that we need to be able to do, all right, is to be able to find the molecular formula based on percentages. Well, thanks for tuning in, you guys, and I hope to see you in class on Thursday or Friday. Have a great day. Bye-bye.